Good evening, everyone. My name is Nate Arnold, and I will be going through my Teach the Doc for Chapter 6, Module 3. So for our first question, we were given the wavelength, whether it's long or short, and given the equation above and what we know about the relationships between wavelength, frequency, and energy. We know that wavelength and frequency are inversely proportional. Therefore, a long wavelength or a large value for that will lead to a low frequency, and a short wavelength will lead to a high frequency. We know frequency and energy are similar, so therefore a low frequency would yield low energy, and the opposite for high frequency would yield high energy. Now for this quantum mechanics table, we were given different orbitals and told to find the possible m values. So for the s orbital, S with 1 orbital, p with 3 orbitals, d with 5 orbitals, and f with 7 orbitals, we have the values of -2, -1, 0, +1, and +2 for D, then -3, -2, -1, 0, +1, +2, and +3 for F. Now we move on to the periodic properties of elements. And so first, for atomic radius, we have just this fundamental property of the atomic and the periodic table. We know that as we go down groups and as we go from right to left of periods, we know that the atomic radius increases. And so first we look at magnesium or barium, which are both in group 2. However, barium is in the lower period. It is further down vertically on the periodic table of elements. Therefore, we know it has a larger radius. Then for silicon or chlorine, we know that when we're talking about smaller, we're looking for the top right, and silicon is also in the 3rd period. However, it is in an earlier group than chlorine, and since chlorine is further to the top right, we know that it has a smaller atomic radius. Then when we look at trends in atomic radius, we look at cations, which are much smaller, because they have valence electrons being lost. So therefore they have less electrons, therefore they have less mass. Then the opposite, so anions, which gain electrons to the outer orbital, they are larger because they're gaining these electrons. They are gaining mass. So we look at essentially this concept here. So which is larger? We have sodium, because sodium 1+ means that it lost an electron. It is a cation. And then we look at nitrogen versus nitrogen 3-, where the nitrogen 3- is an anion, so therefore it is smaller, while the sodium is larger. The nitrogen is smaller because it did not lose those 3 electrons. These lost the 3 electrons, therefore it is smaller. It gained 3 electrons. Excuse me, this gained 3 electrons, therefore it is larger than the nitrogen. And for ionization energy, I'll bring back that chart again. For ionization energy, we know that as we go to the right and as we go up the groups, we know that the ionization energy increases, and therefore for fluorine, which is number 9, which is in the second period, 17th group, then we know that will be greater ionization energy than iodine, which is in the 5th period and 17th group. So therefore it's further down in the list of periods, therefore it has less ionization energy. Then for sodium versus sulfur, they're in the same group, they're in the same period, however they're not in the same group, and therefore since the earlier groups have less ionization energy and we're looking for the smaller, we know that sodium has smaller ionization energy. And when it comes to affinity, electron affinity generally increases across a period, as we know that those elements with more electrons are more likely to hold on to them and take from those who have less electrons in the outer orbitals or the valence electrons. And so therefore when we're looking at selenium or bromium, we know that bromium has a higher electron affinity due to where it lies further right in the period than selenium. And it's 1 group over to the right. It's 16 for selenium versus 17 for bromine. Then for metallic character, we know that going from the top right to the bottom left of the periodic table of elements is metallic character. Bring this back, we have metallic character going down to the left for increasing, and therefore since potassium is higher than the cesium, we know that cesium has more metallic character because it's lower. And for less metallic character, we're looking for which one is in the top right, further top right, and arsenic is in groups 15, whereas gallium is in group 13, and they're in the same period. So therefore, arsenic has less metallic character. Thank you for watching. I hope you're able to enjoy this video.